let me quickly review for you how this works. So again, the surface of the Earth is heated by the sun. The amount of energy that comes out of the Earth, geothermal energy, is a few thousand times less than what actually comes from the sun. So in certain places it can be important, but overall it's the sun that sets the Earth's surface temperature, not the internal temperature of the Earth. And when the sun shines on the Earth, some of it is actually reflected back to space. Again, more of it if it's on an ice-covered part of the Earth or where there's lots of clouds. And some of it is then absorbed by the Earth. And when it absorbs solar energy in the visible spectrum, what happens is the Earth heats up in response because it's absorbing energy. And when objects heat up, they emit their own radiation, but in a longer wavelength. And so that radiation then heads back towards space. If the Earth had no atmosphere, it would be about 30 degrees colder. So we would actually have a frozen planet. We are habitable because of our atmosphere, and because our atmosphere has some greenhouse gases, in particular carbon dioxide and methane, the most important of which is actually water vapor. Water vapor is interesting. We don't often talk about it as a greenhouse gas, but the reason it's important is it's like an amplifier. It turns over quickly. It lasts in the atmosphere hours to days to weeks. And so as a result, you can think of the other greenhouse gases, carbon dioxide and methane, as the dial, say on your stereo, but it's the water vapor that amplifies the effect because it turns over so quickly. And so what happens is these greenhouse gases, they absorb some of the infrared radiation, the long wave radiation, and re-radiate it both back to space and downward, but they act like a thermal blanket. So they essentially keep the Earth's surface warmer than it would be otherwise. And that's how the greenhouse effect works. And again, this isn't just a theory. We can actually say this is what causes Venus to be 460 degrees Celsius. We know this is, in fact, in the laboratory we measure carbon dioxide by looking at how it absorbs long wave radiation.